So I don't have any fancy slideshows with memes or anything on today. It's all strictly business. I should have worn my suit. I'm so serious today.
Kubernetes icon.
Yeah, that's a huge icon.
Which want to draw people's attention to the new.
Yeah.
That'll change. This is all running just locally at the moment. I haven't had a chance to merge it down to master or anything yet. So this is basically just going to go through some of the new pieces we've been putting together for Kubernetes, just so that everyone's kind of got a bit of an idea of where we're at, where we're looking next. And ideally also when this is online, we can get customers to have a bit of a sneak peek at what we've got and get some feedback as well, even pre-release, I suppose. So the first part of this whole process that we've put together is a new account type. So this is token. So I'm just going to preface that with just saying this whole account UI we're looking at possibly rejigging as part of this change, because it's obviously starting to get a bit crowded with different account types and blah, blah, blah. So ignore how horrible some of the stuff looks at the moment. So the new account type is a token, and it is basically just a secure value. So in the case of Kubernetes, that's like a JWT token, so just a basic auth token with claims. Potentially we might reuse this for other places where we need effectively just a single sort of sensitive value as an account, authorization account. We played around with the idea of putting this detail on the target itself, which I'll show you in a minute, but decided that because the Kubernetes target, the cluster target itself, could use a username and password, it could use a token, it might use a certificate in the future, or maybe even a Google or AWS auth. It sort of made sense to keep it all together in the one place. And again, ultimately, because this is a account, it's going to have all its permissions and everything that kind of makes sense for accounts. So it didn't really make sense to put that on the cluster, even though it kind of seems like it's excessive because it's a single string, but consistency is king. So actually, let's see if I've got any of them. No, there's nothing to show there. So the next part of the process is a new deployment target. Again, I think as part of this process, we're going to look at rejigging potentially this target selection page. It's particularly now that we've got the cloud targets coming into here as well. This is easily going to bloat out and become very difficult to pick what you're after. So side note, we'll probably look at rejigging this as part of this Kubernetes work as well. So the new target type is a Kubernetes cluster. So essentially the key details of the cluster target type is obviously the account, which we've mentioned before, which can be a username, password, or a token, or potentially in the future other account types. But you provide the URL that points towards the cluster, so the master that you're communicating with. Because they can be self-signed and potentially if people have got these unhosted, we might have issues with certificates or whatever. We've provided the ability to basically skip the TLS verification if you want. Particularly handy during testing when we haven't given our clusters a proper certificate. And the other key part is a namespace. Now, when we did the original RFC, we didn't really consider how the clusters would be used across environments and how people would sort of petition them and how that would fit into, how environments fit into the whole cluster, given that you've got a single cluster, single target. And the overwhelming feedback we got was that the standard pattern is to kind of use namespaces to kind of petition up environments effectively within a cluster. The nice thing about namespaces is you get things like permission boundaries and resource scoping and that sort of thing. So it kind of fits as a nice way of being able to have a single target, a single actual physical endpoint cluster, but break that up across environments. So potentially you might have one of these Kubernetes targets, you might have the same physical target specified multiple times across your different environments, and your namespace might be, so you might have a different namespace here for each one. Or if you want to use some other mechanism like tenants or whatever, then that's kind of up to the user. They can kind of provide and use whatever pattern makes sense for them. But targets seem like the right way of going about it there. Once you've got your target and your account, as far as infrastructure stuff is concerned, you're pretty much good to go. So we've got, at the moment, a really basic script step. So this is kind of similar to what we've got with the Azure and AWS scripts, where we basically inject a context into the execution process. So when this script is run, we basically take the account, the account that comes from the target that's pulled in by the roles. So there's a bit of indirection there, but kind of fits in with the pattern we're doing with the other target types. And we basically take those credentials, we create a local kube config in the workspace, and then we set an environment variable to specify using that kube config for all sort of subsequent Kubernetes kube control commands. So in this case, when this command is run, it's run within the context of the accounts that were set up, credentials are set up on the account for the specific cluster. So I'm not even going to bother to create, release, and deploy because it's nothing too exciting to see. I'll just show you one that I prepared earlier. So essentially what you end up getting, so in this case, I've got a whole bunch of clusters that we've set up just to test the connection and configuration, etc. And so as you can see, it works currently against the Azure AKS and ECS because they effectively expose a Kubernetes endpoint for you to directly get access to. The AWS ECS offering, though, is slightly different in that it's like their take on Kubernetes. It's their own orchestration system that uses containers. So we plan on probably having a step down the track that deals with that as sort of its own custom standalone step specifically for the AWS ECS. But they have released AWS EKS, which is their Kubernetes offering, which is basically them just hosting a Kubernetes cluster and managing all the infrastructure for that. I haven't managed to configure and set one of them up yet, seeing as that was just released today, but in theory that should work exactly like everything else. I know, right?
As you're about to move on, Rob, to clarify for tips like me, which Azure one's the newer one, the better one?
The AKS is effectively them hosting Kubernetes.
So Azure AKS, AWS, ECS.
There's ECS and
Google's offering. They're the most equivalent to each other.
Yeah.
Just kind of, we'll manage all the infrastructure and give you Kubernetes endpoint.
That's right.
And then Azure ECS is some sort of special variety of it.
So Azure ECS is where they, you basically go and you say, I want to set up a cluster, and you can specify what orchestration type. So they've actually got Docker Swarm. It can be a cluster orchestration type,
Right, okay.
but in this case, we specify Kubernetes as a cluster type.
Yeah.
And then you still say, I want, use these nodes, those nodes. And then under the hood, literally all they're doing is running Kubernetes and exposing a few endpoints that you connect into.
Put an abstraction on yourself.
Yeah. What I think sort of happened is that before Kubernetes kind of won out, everyone came out with their idea of how to, orchestration. So AWS had, I always get them confused, ECS? AWS ECS? Yeah. So they had their version basically, which was their orchestration, where basically they go, you tell us what containers you want to run, give me the configuration, tell us what nodes, what EC2 instances you want to run them on, and we'll manage how many tasks are running across each one. I want min 1, max 5, and kind of managing that scaling. With Kubernetes kind of coming out as the winner in the orchestration space in the past sort of year or so, I think they've all kind of seen the writing on the wall. And so they're now offering kind of native first-class support for Kubernetes as an option, and then they manage all the infrastructure underneath, so you don't need to specify specific EC2 instances or whatever.
Yeah, so we're starting our support with these Kubernetes native
That's right.
Yeah.
As long as we can connect to them as a Kubernetes endpoint, however they do that, then our commands should all just run fine.
Really?
And then we've got one where we've kind of ourselves spun up, as if you're running on-premise, quote unquote. So yeah, and in this case, obviously, as you can see, I've just run a get nodes command. Each one kind of runs within the context of whatever the credentials were there. So that's kind of the state that we're at the moment. We've kind of got that pipeline happening from configuration of credentials to executing something in Calamari. Tested the fact that we can get this isolation between connections. Someone's asking a question, I think, if I can open it. Is Azure Container Instances supported?
So ACI.
What?
Just say no.
I believe so. I'll need to confirm. All these different acronyms and shit always just get me confused. I believe that it should just work because I think they still expose a Kubernetes endpoint, but don't quote me on that. And don't tell me if I'm wrong. Don't want to know. Yeah, so fundamentally, this work we're doing now is all about Kubernetes.
Yep.
So the AWS ECS stuff is out of scope because it's not Kubernetes, it's their own orchestration, but we've got some plans for how we'd manage that in the specs. If anyone wants to have a read, if you're interested in our public repo. And also Docker Compose is obviously out of scope. At the moment, we don't have any plans to necessarily support it, but in theory, a lot of this will set up a lot of the groundwork we need to support Docker Compose. And yeah, well, that sort of brings me on to the next part, which is, basically what's next, what we're planning on doing next. So we've got one step at the moment, which is basically run a script with a Kubernetes context, and you can run whatever you want. We've got a few more steps that we want to get put together before we do a proper full release, so we can have a sort of a comprehensive story of how users will make use of it, sort of regardless of what direction they're coming at it from. So we've got the Kubernetes, kind of first-class Kubernetes orchestration step, I suppose you can call it, where the configuration is sort of very first-class within Octopus, where the users will provide the containers they want with all the configuration and a few other properties that we then will use when we internally run the Kubernetes command. So we'll take a lot of this and effectively either turn it into a Kubernetes apply step or turn it into whatever sort of successive Kubernetes commands that need to be run. But basically that allows the users to think about their deployment in terms of their containers and the things they want out there without having to become experts in Kubernetes and all the different nuances of what to call, when to call. And that will have a few options as well for providing those deployments in with like a blue-green deployment or a rolling deployment pattern baked into the step, which you can kind of do once you're dealing with containers. It's a little bit of a high-level abstraction. The other step type, which we're debating whether or not we'll do as part of this first release or do very soon after, is a Kubernetes apply step. So that is kind of similar to the run script step in that you can sort of source it from a code, source it from a package or directly in line. But basically what the users will provide is the Kubernetes apply configuration, which is a big bunch of YAML. And we'll do inspection on that to find what containers they've listed, and then we expose that to the user when they create a release so they can pick the versions or pick what they need. And so we then take that apply step and we just execute that directly against the Kubernetes cluster. And that's obviously slightly more flexible than this first class approach because that can basically provide any configuration. We'll just run it. But then it's obviously slightly more complex. So it's more for the users who know what they're doing. They're using Kubernetes and they just want Octopus to help orchestrate the packages and the versions, etc. The other step, which again, we didn't originally call out in the RFC, but we got a lot of feedback from people using Helm as part of their Kubernetes deployments, I suppose. And Helm is another layer of abstraction on top of Kubernetes again, that it does a bunch of different things. Some of the key parts are basically having a form of like templating or I suppose a templating syntax on those Kubernetes apply steps. So the problem with the Kubernetes apply steps is what you've given it, everything in there is just what it runs, and it doesn't do any sort of substitutions or templating, or you just switch things in or out based on templates. Whereas Helm is a layer on top that allows users to do that. As well, it's got this concept of charts. And so a chart is, I suppose you can kind of think of it as like a registry of Kubernetes configurations for your own product, but also potentially if you know you need a Nginx node in your cluster, you can say you pull down the Helm chart for Nginx version blah, and it will have all the configuration and all the bits and pieces you need to just spin up a Nginx endpoints in your cluster. So it's kind of making things a lot more sort of composition. So you're putting all the pieces together that you need to build your app, and then saying to Kubernetes through Helm, hey, run all these bits and pieces. It seems like because of some of those limitations that Kubernetes native, quote unquote, had around templating and this composition type pattern, a lot of people, well, Helm seems to be like the standard way these days of actually doing this, orchestrating this whole process. So a lot of the feedback we got from our RFC was, hey, we're using Helm. We'd like to see a Helm step in Octopus. We'd like to just integrate what we've got. And looking into kind of how it would work, it seems like we could probably relatively easily integrate a Helm step into Octopus. And that would involve basically providing the Helm charts as an external feed. So they would select the chart as you would a package. And then there'd be a custom step for using that specific feed type. And then we execute that Helm command through your Kubernetes cluster. Obviously, there's a lot more details there and a lot more things we'll probably discover as we dive into it, but that's kind of a TLDR on that particular area. I think that's kind of sums up. So for the next phase, what we're looking at, to summarize, is the first class step, most likely the Helm step, and possibly not the apply for the first cut. And also, one thing I didn't mention actually is the current script step currently only works on Windows. So with the new worker stuff coming in, I'll need to pull that into this branch and start experimenting with getting it running on SSH. Because again, I imagine a lot of our users coming to Octopus from Kubernetes will have a lot of their scripts written in Bash and they'll be running it on SSH endpoints, etc. So making that available from first go is crucial as well. And I think that's about it. And the other point is that at the moment we're going to assume for the first release, for the first cut, that the kube control tool is available on the endpoint that you're running these commands on, rather than bundling them up in Octopus, like we do with the AWS and Azure stuff, partly because of the fact that if we want to support multiple platforms, we need to do all sorts of platform detection of your endpoint to send the right version across and blah, 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 which we'll probably do down the track, but it just doesn't feel like it's necessary for a first cut to get people using it. Are there any questions or comments or thoughts on the approach or what we're planning on doing?
Your token and the Kubernetes target didn't have a tenant dimension. Is that on purpose or?
Yes, that's a good answer.
Tenants is enabled, or it's in the unless they can see.
No, I don't have tenants.
Oh, maybe that's why. Yeah.
I would imagine because this is using all the same actual underlying, React controls.
Yeah.
It should all just be there in theory once the tenants set up with it.
Yeah.
Ruby.
Cool. Thank you.
Awesome. Is that everyone? Guys, have a lovely day, everybody.